For our final project, we made an LED persistence of vision display. The motors will rotate the LEDs at 400 RPM, and the TM4C inside will control the LEDs and decide which LED is on and off at a given time so that your brain is tricked into seeing a pattern in the air. I'll turn the lights off now so you can see the effect better. Here's a look at the PCB inside of our case. We have a 9V DC power jack to power our motor, and then we have a 3.3V step-down regulator to power our TM4C and power our LEDs as well. At the edge of our PCB is a set of terminal blocks to connect to our motor outputs and our LED signal outputs. Our board uses an Adafruit motor driver that lets us control the speed of the motor with the PWM signal, and we can control the rotation direction using two digital inputs. Now you might be wondering how we were able to rotate our LEDs while continuously sending a signal to them while having no tangled wires whatsoever. We solved the problem by using a slip ring and a custom 3D printed hollow gear shaft assembly. The slip ring has two sets of wires that are connected together internally. One end of the wires is allowed to rotate freely while maintaining a connection with the other end of wires that are connected to the PCB. This is what lets us communicate with our LEDs continuously. Here's a closer look at our LED stick that we used. It has an onboard ATtiny85 microcontroller that processes I2C commands, and then it shifts out the necessary data to the LEDs to make them light up. Arduino libraries already exist for using this LED stick, but we had to create code from scratch to use in our TM4C. This meant lots of digging through the Arduino library source code to see the exact byte structure we needed to send for the I2C commands. Unfortunately, the microcontroller on the LED stick was a huge bottleneck for us. Our original goal was to have actual text display in the air, but the microcontroller could not handle update commands fast enough.